Space and Science News. With James. Our sun dominates our sky, providing warmth and light, but there is another star that holds incredible weight. A star hidden in the Andromeda galaxy. Its light, incredibly faint, has traveled for 2.2 million years. If you looked for it, it would be like searching for a candle in a stadium miles away. A century ago, an astronomer made a seemingly impossible discovery about this star, shattering old assumptions about the universe that has turned science on its head. Our universe is big. As a result of this discovery, all of the science books had to be rewritten and our perception of our place in the cosmos was changed forever. All by seeing this one faint and faraway star. Today we be talking about V1 in the Andromeda galaxy because why not? It's a story of scientific revolution, a mind-bending journey through space and time. This star and the effect it had will challenge our perception of science. And more importantly, the secret still has many unanswered questions for now. Let's dive deep into this subject of V1 in the Andromeda galaxy. For those of us on Earth, the Sun is undoubtedly the most critical star. Our very existence depends on its energy. However, there exists another star, far removed from our familiar solar system, hidden within the swirling depths of the Andromeda galaxy. This celestial object, though insignificant in appearance, holds profound importance for our understanding of the universe. Located an astonishing 2.2 million light-years away, this star's faintness makes it virtually undetectable to the naked eye. It would be like trying to spot a single candle flickering on the surface of the moon. Yet, a century ago, Edwin Hubble's discovery of this star, now catalogued as V1, triggered a revolution in our understanding of the cosmos. Hubble, then an astronomer at the Carnegie Observatories, through careful observations, deciphered a secret written in its light. V1 revealed that our own Milky Way is but one galaxy among countless others. A new beginning came to humanity when they were able to see the universe as a whole. This marked a pivotal moment in humanity's quest to comprehend our place in the universe. We were finally capable of studying the ancient light from distant stars to better understand where we came from. Carnegie Science and NASA celebrated this centennial at the 245th meeting of the American Astronomical Society in Washington, D.C. V1 unveiled mysteries about time and space that continue to challenge astronomers today. Using the largest telescope of its time, the Carnegie-funded 100-inch Hooker telescope at Mount Wilson Observatory in California, Hubble located this unassuming star in 1923. V1 is a Cepheid variable, a unique type of pulsating star utilized as a milepost marker for measuring distances to celestial objects. Building upon this, Henrietta Swan Leavitt had previously made a crucial discovery. She determined that the pulsation period of Cepheid variables is directly tied to their intrinsic luminosity. This groundbreaking discovery opened up the possibility of measuring cosmic distances, allowing astronomers to extend their reach far beyond our own galaxy. A single pinprick of light has unlocked more secrets than anyone could have. Previously, many astronomers believed that the edge of the Milky Way defined the limits of the entire universe. Like sailors in ancient times fearing what lay beyond the horizon, there was a sense that our galaxy represented the known world. It was presumed that if you traveled far enough outward, you would arrive at the edge of reality. However, Hubble's painstaking measurements revealed that V1 resided within the Andromeda nebula at a distance far exceeding anything within our own galaxy. He had meticulously charted the heavens, only to discover that the map everyone had been using was woefully incomplete. This groundbreaking discovery led Hubble to the astounding realization that the universe extended far beyond our galaxy. He had suspected a larger universe existed, fueled by hints and whispers from other observations, but this was definitive proof, tangible evidence that shattered the old paradigm. The scope and scale of that realization was a burden he would come to understand. Overwhelmed, he scribbled an exclamation mark on the photographic plate of Andromeda, marking the variable star's location with a symbol of both wonder and disbelief. Cosmology was revolutionized almost instantly, transformed from a quiet backwater of astronomy into a dynamic field filled with endless possibilities. Upon learning of Hubble's discovery, Harlow Shapley, a prominent Harvard astronomer, was devastated. "Here is the letter that destroyed my universe," he lamented, sharing the news with fellow astronomer Cecilia Payne-Gaposchkin, a moment forever etched in astronomical. Little could Hubble have foreseen that, 70 years later, a remarkable telescope named in his honor would continue his work from hundreds of miles above Earth. What a concept, to continue expanding science after you were already dead. the scientist would have been remembered forever for something as significant. This telescope, the Hubble Space Telescope, made Hubble a household name synonymous with astronomical wonder. Suddenly everyone was hearing the name Hubble, and the scientist reached a level of fame that scientists don't normally reach. Today, NASA's Hubble Space Telescope has pushed the boundaries of our knowledge more than 10 times farther than Edwin Hubble could have ever imagined, making its namesake's early understanding minuscule in comparison. The Space Telescope has unveiled a dynamic universe teeming with active stars, colliding galaxies, and black holes, revealing the celestial fireworks from the interplay between matter and energy. It was as if the telescope was the eyes for humans who could not see what was out there. And everything that has been discovered could not have been possible without the genius who came before. Edwin Hubble initiated the steps that would eventually lead to the Hubble Space Telescope, which has revealed an seemingly infinite ocean of galaxies, each a universe unto itself. He believed that galaxies came in 3 shapes: spirals, ellipticals, and irregulars. These shapes might hold clues to galactic evolution, a question that was partly answered by the Hubble Space Telescope's deep field image in 1994. Now that is all the work it took for his hard work to come to light and change everything there was to know. All the people who dedicated their lives to what it might be. The new understanding and the questions yet to be. The most impactful finding of Edwin Hubble's analysis was the discovery that the farther a galaxy is from Earth, the faster it appears to be receding. It was a revolutionary concept, a departure from the static, unchanging cosmos that had been the foundation of scientific thought for centuries. The universe, it seemed, was not a fixed and immutable stage, but rather a dynamic, evolving entity. It was like seeing a balloon inflating, expanding in all directions at once. This groundbreaking conclusion rested on Hubble's careful correlation of galaxy distances with the reddening of light, a phenomenon known as redshift. Redshift, like the change in pitch of a siren as it moves away, stretches the wavelengths of light, shifting them towards the red end of the spectrum. Hubble noticed that this redshift increased proportionally with distance. The farther a galaxy was, the more its light was stretched, indicating a greater velocity of recession. It wasn't just a curious observation, it was a key to unlocking the secrets of the universe. Redshift data was initially collected by Vesto Slipher at Lowell Observatory, who spectroscopically studied those mysterious spiral nebulae a decade before Hubble. Slipher didn't know they were extragalactic, he didn't know that they were separate. However, he had laid the groundwork for those who would come after. Slipher initially interpreted his redshift data as the Doppler effect, which meant, according to Slipher, galaxies appeared to be moving away from Earth. It would be Lemaitre to come to a new conclusion that would lead to a scientific revolution. Georges Lemaitre analyzed the Hubble and Slipher observations and concluded that the universe itself was expanding. The galaxies weren't simply moving through space, but rather space itself was stretching, carrying the galaxies along like leaves on a flowing river. This elegant relationship between galaxies' distances and redshifts is now formally known as Hubble-Lemaitre's law. The understanding of the cosmos changed forever. Because the universe appeared to be uniformly expanding, Lemaitre proposed a thought experiment. Imagine running the expansion rate backward in time, like rewinding a cosmic movie reel. As you go further and further back, the universe would become increasingly smaller, hotter, and denser, compressing all of existence into a volume almost beyond comprehension. It was from this line of reasoning, though not initially named by Lemaitre himself, that the concept of the Big Bang began to emerge. The term Big Bang itself wouldn't enter common usage until 1949. This new view of the universe, while groundbreaking, did create a challenge for one of the greatest scientific minds. This new view of an expanding universe offered a solution to a problem that had vexed Albert Einstein. The physicist had deduced that the universe could not remain stationary without collapsing inward under the relentless pull of gravity. Lemaitre helped support this. The rate at which the universe is expanding is a critical value to understand and is now formally known as the Hubble constant. What does all of this even mean? Hubble laid the foundation that we need to understand the vastness of everything. What we come to know has expanded into what we know today. After decades of meticulous measurements and refinements, the Hubble Space Telescope was eventually able to nail down the expansion rate with remarkable precision. This resulted in astronomers pegging the age of the universe at approximately 13.8 billion years. This achievement hinged on accurately establishing the first crucial rung of what astronomers call the cosmic distance ladder. A series of techniques can then be employed to measure distances to increasingly far-flung galaxies. But the story doesn't end there. Just as scientists thought they understood what the universe was, another piece of the puzzle was revealed. In 1998, the Hubble Space Telescope and other observatories made a stunning discovery. The new discovery shifted everything, and everything scientists thought they knew was wrong. The universe was not only expanding, but its expansion was accelerating at an ever-increasing rate, driven by some mysterious force. It has been called dark energy. The mystery remains. So, what are we left with? A small star, millions of light-years away, transformed our view of everything. Edwin Hubble's work, and those who followed, showed the cosmos is far larger and stranger than anyone ever imagined. It's a humbling realization. To think that our entire galaxy, with billions of stars, is just one of countless others. And all of that was made possible by a faint flicker of light that took millions of years to get to us. What a concept! The science continues. Mysteries remain. Dark energy pulls everything apart. We don't know the cause of this or what it means for the future. There is so much more that is unknown at this moment. The new telescopes will tell a new tale. Who knows where science will take us, who knows what we will find. If you were amazed by this scientific journey, please share this video with your friends, family, and everyone. If you want to see more videos like this about the cosmos and all of its hidden wonders, subscribe to our channel. Ring the bell if you want to be notified. A big thank you for watching and joining us on this ride through the stars. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.